Hello everyone, welcome back to my channel. So today we are going to do Leetcode daily challenge, Decode phase. So let's read this question, and after reading this question, then look for the constraints, and after that I'll explain you that how we are required to do this question. Basically building up the intuition, and after that how we are required to code the same. And then we will be discussing about the time complexity and the space complexity. So basically in this question, as we read out, a message containing letters from A to Z can be encoded into numbers using the following mapping. Basically, A is encoded as 1, not as 0 but as 1. And similarly, Z is encoded as 26, as you can see here. So now the thing is, to decode an encoded message, all the digits must be grouped, then mapped back into letters using the reverse of mapping above. So reverse of mapping, that simply means that 1 is required to be decoded as A, 2 is required to be decoded as B, or if there is 22 given, then 22 could be decoded as 2 times D, or it could be directly decoded as whatever comes for 22. I don't remember, might be S or T would be there, which correspond to B, 22. So now that's all. So that's why they are saying that there may be multiple ways for decoding the same string. For example, 1106 can be mapped into, here you can see 1106. For 1, it could be mapped to A, then again for 1, it could be mapped to A, then for 10, it could be mapped to J, and for 6, it could be mapped to F. Then comes the part for 11, and then 10, and then 6. So it is mapped as KJF. So according to all these things only, there are various ways to decode a particular string. So note that grouping 1, 11, 06 is invalid because 06 cannot be mapped to F, since 6 is different from 06. This thing which we are required to consider. The thing is that nothing could be starting from 0, but it could be ending for 0. Basically 10 could be considered, but 01 can't be considered. So that's the scenario it want to say here. Then it says that, so from this only we are able to figure out some base cases, that if we are having 0 at the starting, then at that moment we are required to return 0. Means basically no other way is there to decode that particular. But if we are able to figure out 0 after a particular digit, means after 1 or 2, 2 also, then only we can consider that 0. So this is one of the edge case which we are required to handle. So we need to take care while coding. Then given a string S containing only digits, return the number of ways to decode the same. So that is the only thing which we are required to return. So the thing is that in this particular string which would be given to us, we are required to return number of ways. Basically there could be any number of ways in which a particular string could be decoded. So that we are required to return. And then it says the test case are generated so that answer fits in 32-bit integer. So basically all these test cases won't give us TLE in that sense, because our S would be in that still 30, means it would be a 32-bit integer only, not more than 32. So here you can see that S length is basically 100. So when we would, the answers which would be coming for this S also, means in that scenario, that means when we are combining them, then at the end the answer which will be coming up, it will be in the range of 32 bits only. So that's what they want to say. That contains only digits and may contain leading zeros as well. So we need to take care of that thing also. So these were the constraint and the question walkthrough for the same. Now comes the part that how we are required to build intuition for the same, means about the each test case and so on. You can figure out that in each string which is being given to us, we are required to figure out with the number of ways. And when the part comes for number of ways, right, we are required to figure out with a lot of varieties which could be there. So in that scenario, our recursion and backtracking comes into picture. But as the constraints are in such a manner that here recursion backtracking won't work much. So that's why in that scenario, we are basically required to memorize or go ahead with bottom-up DP for this solution. But before going ahead with that particular solution, we are required to check first that what would be its recursive solution. So let's head over to that type of solution. So now, as here we can analyze, the thing is that okay. So as here we can analyze that our input is basically a string, right? And whose range is basically between 1 to 26, because 1 stands for A and 26 stands for Z, right? And even in that also, as we are required to go ahead with this thing, that either we can have a single digit decoding, or we could have a 2-digit decoding, right? So that's why we are required to split those things as well, because when we are going ahead with a way for 1 digit, it would be somehow different, and when we are going with the 2 digits, then again it would be somehow different. So that things we are required to check. So when it comes for the single digit, then the range should be between 1 and 9 only. It shouldn't be 0. So that's the thing which we are required to handle here. Then when it's in the range of 10 to 19, then all digits are fine. This is type 1 double digit. And when it's between 20 to 26, then it should be in the range of 0 to 6, not more than 6. So this is the double digit type 2. So these are the things which we are required to handle in our solution. Now comes the part that how recursive solution would be like. So here's the part. Basically this question is all about that we are selecting for the single digit or we are selecting for the double digit. So here if we take the first that second example which was there for 2 to 6, right? So if we select just 1 digit, that's why I put here 1, then only a 2 would be selected, right? So I selected this 2. And if we select 2 digits, right? So then 22 as it is would be selected. So that's why I selected as 22. Then if we further go into the tree, we select only 1 digit, then next 2 would be selected. We select 2 digits, right? So at this particular moment, if we select 2 digits, then further 22 would be selected, right? And then, but one more thing I was thinking, that here not 22, but here 26 would be selected. Here 26 would be selected. Basically the next part which is being there, that would be selected. But after that, if we want to select either a single digit or double digit, then nothing would be selected. So there would be ending at this point only. So our solution basically would be till this point. So this is one of the possible way for decoding the same. So that's the scenario here. So here, when 1 digit is being selected, then 2 is selected, then again 2 is selected, and then 6 is selected. So this is one of the way for decoding. Then when we are going ahead with this, then there is no possibility when we can select 2 digits, right? So here 26 is being selected, and after that nothing would be selected, because this is the end case, it has reached the end point, right? So here this is one more way to select this. And then if we go for 2 digits, then if we go for 2 digits, then when 1 digit is being selected, that's 6. So this is one of the way. But we can't select any more digit after this, means in 2 digit scenario. So that's why there are basically 3 ways in which we could decode this, and those 3 ways are something like this. Basically those are 2, 2, 6, that is B, D, and 6 would be A, B, C, D, E, F. This is one of the way. Then other way would be 2 and 26. So that would be B and Z. And the other way around is 22 and 6. Yes. So I don't recall that what is 22, and 6 is basically this F only. So these are the 3 ways in which we can select out of these, we decode it. So answer here would be simply 3. So that's the whole scenario here, and how we would be doing for this particular. So this was about the recursive. So you can clearly see that basically the size of the height of this particular recursive tree will go till n. At max it will go till n, right? You can see that 2, 2, 6 is the 1, 1 selected. So that's why height is basically n, and the number of possibilities is basically because we are selecting at every point as 2 parts, right? So that's why it could go up to 2 raised to power n. So that's why our time complexity is basically 2 raised to power n, and the space complexity is order of n. Because in this stack, at max n elements would be there. So that's the scenario. Now, how we are required to write the recursive code for the same. So in a recursive code, what all we are having? We have the options, the recursive, the recurrence relation, and the base case, right? So the option which we are having, either we can select one digit or we can select double digit as it was shown in the recursive tree, right? So that's why we are having two options. So from that two options only, the recurrence relation would be like this, means either we are taking only one digit, right? So that's why we have done I plus 1, or we are taking two digits, that's why we have done I plus 2. But these things are also on the basis of some conditions only. How we can take that I plus 2? Here at the starting I had told that basically for selecting that two digit, there are two types of digit scenario. So that would be the if condition which we will be writing, that I is basically less than n minus 1, and if s of I is basically equal to 1, then we can go ahead with the I plus 2. There is no issue, right? Because when it is 1, then it can go from 0 to 9. That was simply there. But if it is 2, then the second digit which is there, it is required to be less than 7, because we have letters till 26 only. So this is the if check which we are required to write. And the base case in this scenario would be, as I had already told, that if it is 0, then we will be returning 0. And other base cases, because we are traversing on the length, right? So that's why if I, that is the iterator for length of the string, if it is equal to the size of my length, then I will be returning 1. That is, we have till now found one answer, means one way. Here, as you can see, then it was at this particular point. So here it would have been returning 1, and here also it have been returning 1, and here also it have been returning 1. So that's the scenario which I am saying. So this was all for the recursive solution. But as I told, that is the constraint which are being given to us. It is not about doing a recursive solution. It requires to be much more simpler than 2 raised to power n time complexity. So that's why we will be memoizing this solution. So for memoization, the key components are basically selection of a DS. So here, as we can see, that there is only one variable thing, that is according to the length only. So that's why we will be choosing 1D data structure. We will be initializing that vector, say we take it as temp, means its name is temp. So with -1 we will be initializing that vector, and then in the recursive function, when temp is not equal to 1, then we will be returning the value, and because of this fact only we are memoizing this particular solution. And how we are getting the values into the temp, that is that whatever answer we were storing earlier as the recursive solution, now we will be storing that in the temp. So this is the thing which we will be doing for the memoization. And here the time complexity will become order of n, and the space complexity will become order of n as it is, because of the temp we will be taking. Now comes the next part about the bottom-up DP. So in bottom-up DP, basically we are having transition and state, right? So here time complexity would be again order of n and space complexity, but here what we are doing, we are just making the recurrence relation which is there as state and transition. So that's the thing which we are doing in this particular. So now as transition would be dp of I plus equals to dp of I plus 1, then we are just choosing the one digit, and dp of I equals to, means we will be adding also I plus 2 when it satisfies the condition of two digits, the thing which we were writing on recurrence relation as well, and the state would be dp of I. Basically it is a 1D vector, so that's why state would be like this. So this was all which is required for our solution. Now comes the part that how we are required to code it. This was somehow the algorithmic part, that this is the things which we are required to think before coding our solution. Now let us go ahead that how we are required to code this solution. So basically we need to find a number of ways in which we could write that, right? So our recursive solution would be of this particular time complexity and space complexity, and n is basically less than equal to 100 as it was given in constraint. So length of the string of char may be decoded alone or by pairing with the next char. So that's the thing here. So here, this is that main function which is being given to us. So basically we are calling our recursion which is being there. So we are passing a string and the starting index. So this is how we are going ahead with. And then, yeah. So here first we are checking for if it is equals to the length of our string, then we will be returning 1. And then we are starting with our answer as the 0 at the start. And then if our s is not equals to 0, this is the condition which we are required to check for a single digit, as there shouldn't be any leading zeros, right? So that's why. Then at that moment only we will be going ahead with s and I plus 1 condition for single digits. And then these are the conditions basically for our double digit. Means for the first type of index, that is when it is from 10 to 19, then we can directly check for the 1. But if it is si equals to 2, that is from 20 to 26, so in that scenario we are going to check by this. And then if it satisfies this condition, then we are incrementing the answer in our answer by increasing the I plus 2, and at the end we are returning our answer. So this is what we are required to do for a recursive solution. Now comes the part that how we are required to memorize this particular solution. So in our memoization part, we are taking this particular vector, a 1t vector, and in this we are resizing it with the 100, as in the constraint it was given that 100 is the size of the string, and minus 1 from that we are initializing. And then if the size is basically equal to the string, then we are returning 1, because now we can't go much farther. And if our memo of I is not equals to minus 1, that is, it is having some answer, then we will be returning memo of I, and our answer would be equal to 0. This is the condition which we were saying using there and storing that into our answer. And then again the same thing, but then at the end whatever answer we are having, that we will be storing in our memo. So that's the thing which we are required to do here. So this was the memoization part. Now when it comes for the bottom-up DP, all what we are required to do is whatever we were using here and whatever we were using in this recurrence relations, we will be directly now converting that to our vector which was being there, is to our bottom-up DP. So here what we are going to do here is that DP of n is equals to 1. That simply means that at last whatever is there, a single digit which is being there, we are taking it as the answer, means the base case here. The thing is that when it reaches at the end, right, so there we return 1. So here that base case is handled in this manner, and the sizes basically we are taking at n plus 1 and 0, so that base case is being handled perfectly. We are starting from the last, and then here we are checking the same things which we were checking in our recursive solution, that if s of I is not equal to 0, that is there is no leading 0, then what we are going to do, whatever I we are having, whatever percentage we are having, then in that we will be adding up the I plus 1 for the single digit. Means basically whatever answer is being stored, or count is being stored at this particular state, so that we would be storing in this state. And if this satisfies this particular condition, that is the 2-digit condition, then according to that we will be storing in this. And at the end we will be returning whatever is being stored at the 0th index. So this was all for this particular solution. Hope you like the explanation. And if you like the explanation, so please do like and subscribe to my channel. And please do share among your friends. So yeah, this was all. Thank you.